Now see here intrinsic semiconductors. You know intrinsic semiconductors are pure elemental semiconductors like germanium or silicon. You know for germanium around the this energy band gap is around 0.72 electron volt and silicon it is 1.1 electron volt. This is forbidden energy gap. Now conductivity of the semiconductors depends on temperature. If you take energy band for the semiconductors intrinsic like a conduction band and this one is here a valence band. Valence band has got valence electrons over here and this is the energy gap here. Conduction band is empty almost, there is no electrons. Now at T is equal to 0 Kelvin, there are no free electrons in conduction band. So, this semiconductor acts as an insulator. So, semiconductor at 0 Kelvin act as insulator here. Now, look at the another part here. If you give some temperature, if you give some energy, then what happens? As you give some energy, these electrons jump from here to here and here empty space is here formed. So, when one electron goes from valence band to conduction band, one empty space is created. Similarly, when another electron goes here, so another empty space is created. When another electron goes from here, so here the another empty space is created. So, these are called actually free electrons and these are called empty spaces are called here holes. So, at room temperature, electrons from the valence band starts jumping to the conduction band and electrons become free and in the valence band empty spaces are created, these are known as holes. So, now in this case the conduction of current starts. Now see, if I take here the example of the silicon crystal here, suppose you have taken one silicon atom over here which has got the 4 valence electron. Another silicon atom is over here which has got the 4 valence electron, one is here and here 1, 1, 1 and silicon like this and here so every silicon atom has got the 4 valence electrons. Now these bonds are formed. There is a formation of the covalent bonds here. When you give some energy, so as the energy falls on these crystals, these semiconductors, this electron suppose becomes free here. So, this is taken as a free electron. As this electron become free, so there is a space which is known as hole. So, this is empty space is known as the electron becomes free here. So, this empty space is known as hole. So, when energy falls here, electron becomes free and holes are created. When more and more energy falls here, so you know the electrons from this band, this bond will come to occupy this space, so another hole is created. By this way, formation electrons keeps on becoming free and you know the new holes are created. But in this process, you will see here, so electrons from the other bonds comes to occupy this empty space, so the here behind they leaves an empty space. Similarly, to another bonds are broken to occupy the previous space, then the another way the hole is left behind here. So, by this way electrons are becoming free and holes are created, but you will find in this case Ne is equal to NH is equal to Ni. Ne is called number of free electrons per unit volume and NH is called number of holes per unit volume and Ni which is equal to Ne equal to NH number of intrinsic current carriers intrinsic carriers per unit volume. So, this is about the intrinsic semiconductors. So, we have seen energy band diagram for the intrinsic semiconductor and formation of electrons and holes, and we get the total current I is equal to IE plus IH. So, electrons and holes are responsible for the flowing the current, and the total current is the sum of the current due to electrons and holes.